In the previous section, we talked about patterns of missingness, and recall that patterns describe where data are missing, or they indicate the location of the missingness. Mechanisms, on the other hand, describe why data are missing. And we have a few possible mechanisms that could be working in our data that explain the reason for the missingness. And these reasons could introduce bias into our results, usually of the type 1 variety. So it's important to know these mechanisms so you can know if they may be working in your data, although I must say up front that there is no proof of knowing exactly which ones are at work in your data. So these are hypothetical. It kind of reminds me of the type 1 or type 2 error. We really don't know for sure when we're committing it, but it's good to know it anyway, because then you can at least understand the different threats to inferences that could be operating in your conclusions that you make. So with that in mind, let's take a look at the first kind of mechanism that we can have, and this is the most favorable one. We would want this to be happening in our data. I don't think it happens super often, but I have seen it come up, and there is a test in SPSS for this, so it's very helpful, which I will show you later. But this is basically the MCAR mechanism, and this means that the data are missing completely at random. What that means in layperson's terms is that the reason the data are missing is unrelated to the missing values themselves or a variable that's related to the outcome. So for example, what this is really saying is that people in your data set who are either high or low on certain traits, whether they're measured or not, are not more or less likely to provide incomplete data. So unpacking that further, let's say that we have some kind of relationship such that people who are high on negative affectivity are more or less likely to score a certain way on the outcome. So we have negative affectivity related to our DV somehow. And let's say we have people who are high on negative affect. They are more likely to skip items, maybe because they are just more irritable, or they're frustrated with some kind of item. Maybe there's a triggering point of an item or a scale that would trigger an NA person to avoid answering that particular item. If that then is, if that negative affectivity trait is related to the DV, then you're going to have a bias in your results. So that is a case where we don't have data missing completely at random. Okay, so the missing completely at random would say that people who are high in negative affectivity are no more or less likely to give us incomplete data than those who are low on negative affectivity. Okay, so we have some kind of variable that is impacting our DV or associated statistically with a DV. And if those people who have that particular variable, that trait, if they are more or less likely to give us incomplete data, then we have missingness that's correlated with something, and that can bias our results, which I will talk more about later. But that is an example of the opposite of MCAR. Okay, so MCAR means that the reason for the missingness is not correlated with anything. So it's completely random. You can't predict it. It cannot be predicted, which is the definition of random. Random means that we cannot predict the values. Okay, so the reason the data are missing is completely random with respect to all variables related to the outcome or the missing values themselves. So another example of this, imagine that you are measuring high school students' math scores, and some of the students were randomly selected to go on a field trip that day. Okay, so they missed the math test. So in this case, they would have missing data, but it would be random. It would be MCAR because the students were randomly selected to go on a field trip. It was not the case that that only children of a certain age were missing that day. So we would have age as correlated with the missingness, predicting the missingness, in other words. It was a completely random kind of event that caused the missingness. So when this is the case, our results are not going to be biased when we have MCAR. When we have MCAR, we can use probably listwise deletion. So that's a method that I'll explain in a bit, but it's basically that you can eliminate a whole case that has any missingness in that case. You can just eliminate them so you can have an end data set that has complete data. So you could use that method in cases of MCAR, and you wouldn't have biased results. Okay, so MCAR means missing completely at random, and this is the idea that the reason for the missingness is not related to any variable either measured in the study or unmeasured in the study. If there is an association, then that is a different mechanism, which I'll describe in following segments.